Good morning. Welcome to Start Power System Ventures, a renewable energy company in solar, wind, and hydro. We are fully into the business of renewable energy, and we also train upcoming engineers. We mentor them to the stage that they too will be able to stand alone as an entrepreneur. We are deep rooted in electrical engineering, that's our background, and we have many affiliates and partners. We are trained by both Nigerian and the European. Now, our first section is introduction to solar and inverter. First of all, what is an inverter? An inverter is an electrical electronics component that converts DC, direct current, to AC, alternating current. Direct current is the current we get from batteries and solar panels, while alternating current is the current we get from NEPA source and generators. So the machine that converts DC to AC is what we call an inverter. Then how does the idea of inverter, how does it come into being? In the past, even when the president of a nation is doing national broadcast, there used to be blackout, there used to be power cuts along the way, and the whole TV studio will be blank. They will not be looking for the way to on generator or to look for alternative. So this is what makes technologists to start thinking of what is going to bridge this gap. And in 1997, a technologist, Samuel Grail Barnes, Samuel, Samuel, Grail, Greyl, and Barnes, Barnes. Samuel Grail Barnes, a technologist, invented an inverter. That time, Samuel Grail Barnes was working with Toshiba Company, Toshiba. That was when, in conjunction with his company, they invented an inverter. The first set of inverter that was installed was just an inverter that just inverts DC from DC source, which can be battery or DC power supply or solar panel, then convert it to AC. Then as time goes on, it is being modified to conventional, modified to solar hybrid, then later modified to grid tie. So that leads us to types of inverters. What are the types of inverter that we have? Types of inverter. The first type of inverter that we have, this is how it looked like. The first type of inverter that we have, we call this type regular inverter. Regular, regular inverter. Regular inverter. You have regular inverter. You have conventional inverter. we have solar hybrid inverter, then grid tie inverter. I will explain everything. This is an example of a regular inverter. What is peculiar to regular inverter is that it only has input. It only has input and output. It only has one input, then one output. And what it does is that it just got DC. This is the terminal for DC from battery. Then through the oscillating circuit here, the MOSFET and other components. MOSFET is MOSFET is a feed event transistor. Feed event transistors that did the work of oscillation, that is oscillating the DC to the form that it will form an AC. We know that AC is sinusoidal in nature. Sinusoidal, SINUSOIDAL. You can Google that. Sinusoidal in nature, AC. But the DC that the inverter will get from battery is straight line. But when the alternative direct current that will come from the battery gets to the oscillating circuit, the oscillating circuit turn into this form. It turn it to sinusoidal form. That is AC. So this is a regular inverter. You get DC here. This is a small inverter, regular inverter. Get your DC here with the aid of your plug. Here you tap for maybe TV, fan, or anything that you want to power. Then the second type of inverter, which we will talk about, is conventional inverter. That is the upgrade of regular inverter. The conventional inverter has input from battery, output, the AC output as the regular. It also has AC input from NEPA or generator, which it uses to charge battery and at the same time power the load, power the appliances, the house. You can see the upgrade. Before, they will take the battery to an external charging unit, then bring it. Whenever NEPA take light, immediately they will change it manually to the alternative source. But technology still reason that the time frame, the transfer changeover time can still be minimized to a negligible interval. That is why conventional inverter can switch over with the help of a relay within a twinkle of an eye. Not that when NEPA take light, you will now be looking for one socket to remove, one switch to on, the socket to change. No, it will automatically trip over with the help of a relay. I will do the schematic diagram on how a conventional inverter will work, and I will present it at the end of this class. Yes, that those. Then the third type of inverter that we discuss is um, solar hybrid. What is peculiar to solar hybrid inverter is it has all the features of conventional inverter, which is input terminal from battery, input from NEPA, then common output to appliances AC. But solar hybrid also has inbuilt solar input that has a solar charge controller. What is the work of a solar charge controller? It charges battery with the help of the sun power. Then it regulates the amount of current on the battery. Once it is full, the solar charge controller will be the one that will stop the inflow of the DC voltage from the solar panel. Then it also boosts the power of the solar panel. It does the work of an amplifier also, current amplifier. That is the work of so a solar hybrid inverter has inbuilt solar charger, what we can call solar charger. You remember, a conventional inverter only has a rectifier, which is inbuilt NEPA charger that charges battery, and at the same time it supplies the house, but it doesn't have a solar charger. But solar hybrid inverter has both NEPA inbuilt charger and solar inbuilt charger. That is the difference, and it is synchronized together. It is connected in a way that the three solar input, battery input, and NEPA input, they work together. If what first comes is NEPA and it has charged it full, when day break and the sun come up, the controller will not charge because of the power it has met on the battery. So they are working together, not that they work separately. It is synchronized together. Then the last type of inverter we are going to discuss is grid tie. This inverter is not yet common here, though we have it here in Nigeria, but it is not yet common. It's a grid tie inverter. It is mostly used in China, in the UK, in Germany, and the rest. It is an inverter that works without battery, and it works with the national grid. When national grid comes, it is the national grid that will power it up. If there is no national grid is not available and it is in the night, the system will not work. So it is either it's powered up by the solar panel or the national grid. And the beauty of this is that the owner of the inverter or the solar system can sell power to the government through their metering system. How does that work? Is that when there is enough power from the sky, from the sun, and there is still national grid, there is still what we call NEPA here, there is still NEPA, and the owner of the house is consuming, let's say the power they are getting from the sun is 10 amp, and the owner of the house is just consuming 2. Maybe the family are not around, or maybe they don't require putting on appliances. So the remaining heat will be fed back through the national grid. The national grid will add it to their power bank and use it to feed other consumers, and they will credit the owner. So this grid tie inverter, once it is connected with NEPA or solar panel without battery, it power on and it begin to operate. That is grid tie inverter. So the types of inverter that we have now, we have regular inverter, we have conventional inverter, we have solar hybrid inverter, and we have grid tie inverter. Regular inverter is the one I said is the earliest type of inverter that has only the input terminal from battery, then output to your appliances, which is AC. Just its only work is just convert DC to AC, no other work. Then the conventional inverter is the one that incorporates charging unit, rectifier, and bypass relay. It converts DC to AC, it charges battery, then when NEPA is available, it bypasses to your appliances, to your load direct, while charging battery. This I will demonstrate in a schematic diagram that I will put across at the end of this class. Then the grid tie inverter, I said, is not common in Nigeria now because our metering system is not well organized. We don't even have a good metering system that make solar owner to sell power to the national grid. In abroad, a solar home owner that is using a grid tie inverter, all the sun that is solar generates, that he generates in the afternoon when he was not around, can be sold to the government and they will credit his account through grid tie inverter. Yes, there was the next topic is list of tools as a solar engineer. As a solar engineer, you must have some tools and you must be familiar, you must know what to use them for, and you must be very, very adapted to how we use it. For example, we use an hammer. Everybody know an hammer on site. If you don't know how to handle an hammer very well, it can injure you. So you should know the technical know-how of how to handle an hammer. Then we have multimeter tester, which I refer to as our oracle. In the olden days, when our forefathers don't know what is happening again in their community, they go and consult their oracle, and it is the oracle that will tell them, look, this is it, this is that, it is this mountain that you people are sacrificing for before, that you are not sacrificing for again, that stop rain from falling, that send measles to be affecting your children, which I don't believe in anyway. But multimeter tester is what tell us a lot of things on our systems. For example, if a customer call me now and say, my new battery Maybe you tell me that it will last for 10 hours. But when immediately we come home by 8, before 12, it's telling us low battery. What is happening? So when I get there, I'll just take my multimeter. This is a typical multimeter here. This is a typical multimeter of which we are going to practice it really on site, because this is just introduction. Yes, I will switch it. I will switch my multimeter to desired range, then ask them to put on all their loads, all the load that they put on. Then go to my battery terminal, the positive terminal of my battery, the final output that go to the inverter. Then I take my reading through the clamp on DC ammeter. When I get the particular amps they are consuming, after let's say 5 minutes, I can get the particular amps consumption of that house. Then with that amp consumption, I can divide it by the total watts. I can divide it by the total amps hour of the battery bank. That will tell me exactly what is wrong. If the load is minimal, that will tell me actual number of hours that load is supposed to last on the battery. So you will need a multimeter, you need a drilling machine, you will need set of screwdriver, you will need hand tester, you will need hand blower. In some stages we will need our oscilloscope, we need our tape. Then at times we need soldering iron. We need Allen keys. Then battery tester. We have different type of battery analyzer, different type of load detector. We need the tubular battery acid density gauge, battery tester. Then we need set of flat and socket spanner, and so on. Those are the tools that you will need as a solar engineer. But it's not compulsory you have everything at a go. It's not compulsory you have everything at a go. You can start the basic things. Your multimeter tester, very important. Screwdriver, very important. Then battery tester, that one can save you millions of naira, can save you some harassment from customer. Now, what is the next topic is inverter inverter connection categorization. Inverter connection categorization. Inverter is categorized by the way they are being connected. There are common neutral connected inverter. There are non-common neutral connected inverter based on manufacturer's configuration. Based on manufacturer configuration. When I say common neutral inverter connection, there are a set of inverters that their connection is not that input live and neutral, then output live and neutral. No, because they have inbuilt common neutral. When you put their input to be live and neutral, the output is not necessarily live and neutral. Only live will work at the output. Because why? Because they have inbuilt common neutral. This inverter, this common neutral inverter, if you install them live and neutral input, live and neutral output, there won't be problem. But if it is live and neutral input and only live at the output, it will work. So why wasting cable? It already has a inbuilt common neutral. But the second one, which is a non-common neutral inverter, is the connection is live and neutral input and live and neutral output. Live and neutral input, live and neutral output. If you install this inverter like the common neutral, this inverter will blow off immediately. It will burn. It is so we have to be very sure from the manufacturer, is it an inverter that have inbuilt common neutral or the one that doesn't have inbuilt common neutral. If it is installed the way of common neutral, which is live and neutral input and only live at the output, it will blow up. It is the normal connection for it is live and neutral input, live and neutral output. Don't try live and neutral input and only live output on non-common neutral inverter. And most Indian inverter, because they are the best manufacturer of inverter in the whole world. Yes, Sukam is the best inverter company. Yes, they won international award. So most Indian inverter is common neutral inverter. It's common neutral inverter. While most Chinese inverter are non-common neutral inverter. Most Chinese, not all, are non-common neutral inverter. That is the mode of inverter connection. That is mode of inverter connection. Mode of inverter connection. So let's go to load estimation on inverter and choices of inverter. We don't just use the same inverter for different clients. There must be load analysis and load estimation. A shop of 2 computers, 1 fan, 2 bulb lights, and maybe one table fridge cannot be given an inverter that will give a bank of like 50 computer systems, 24 air conditioner, and some other things. So we need to do load estimations. What we mean by load estimation is we check if they have bulb. How many bulb do they have? What is the power rating of each bulb? On a bulb, you will see they will write something. They will write like 15W. That is the power rating of that bulb. Watt. The unit of power is watt. So when you calculate how many bulb, how many fan, what's their power rating, which we are going to do, I'm going to do proper analysis of the load estimation as time goes on. I'm going to do proper analysis of load estimations. How we add after getting, okay, let's assume a customer has 5 bulbs of 15 watts, two fans of 75 watts, one TV of 120 watts, then one fridge of 200 watts. How do we do load estimation for this type of customer? You will draw your table. You start by serial number. Load. What is the load? Let's say bulb number. What is the number of, how many number of bulb? 5. Watts. What is the wattage or power rating of that bulb? 15. Then when you multiply by 5 by 15, what do you get? You get 75, right? That is the total power rating of all the bulbs in the house. I will do the proper tabulation of load estimation. Then load estimation and choice of inverter. Then that's if 75 is the total watts for all the bulbs, then add fan, add TV, add fridge together. So their total watts plus additional tolerance of 25%, which I'm going to calculate, do the calculation at the end of this class, is the size of inverter that you are going to choose for that client. Then that is one for load analysis. Then another thing is, in choice of inverter, you choose, is it a short period of time? Do they require short backup time or long backup time? There are customers that lives where NEPA rarely comes. And you know, solar panel charges slowly. What are the loads that they want to power? Is it just ordinary bulb, fan, and TV, normal home appliances? We call them resistive load. You can choose an inverter that is lighter on battery. An inverter that is lighter on battery. We call them transformerless inverter. That brought out us to another type of inverter, so which is transformerless inverter and transformer inverter. Transformer inverter are mainly for heavy loads that require short backup time. Heavy load that require short backup time. Heavy load that require short backup time. So we understand this better when we get to site, when we are fully into the business. The type of inverter we choose depend on what is going to be the purpose of use. It depends on the purpose of use. It depends on the purpose of use. Due to the adaptation of Nigeria's situation. So if you can use transformerless inverter on heavy inductive loads, so the inverter will be getting excessively hot, and there will be error and breakdown always. It's going to be giving fault always. When something is getting excessively hot all the time, except the client can afford several of that transformerless inverter that is linked together in parallel, and which is even uncalled for when you can get a transformer type that is cheaper and that will carry the load without being excessively hot. Choice of inverter. It is number one, it is determined by the size of the load. Number two is also being determined by what the nature of the load. Is it just light resistive load, or is it heavy is it very heavy inductive loads? We will understand that better in the course of our program. We understand that better. You can also Google inductive and resistive loads to get more understanding on this. Then the next item is the difference between home UPS inverter and online UPS. In modern day renewable energy, we have different categories of power backup systems. We have home UPS, we have inverters, and online UPS. Home UPS are small systems that we can equally use to power our appliances in case of power cuts. They are basically the smaller, all those smallest size of inverter. We call them home UPS, like inverter of 650 VA, 900 VA, 1000 VA, 1500 VA are under that category, home UPS. They are under that category, home UPS. Then the inverters start from 2.5 kVA. They can start carrying fridge. 1 horsepower AC, 3.5, 5 kVA, and so on. Those are inverters. Then this online UPS, what segregates inverter from online UPS? Inverter and online UPS are the same, but what separates the two is that the online UPS has zero, approximately zero changeover time for sensitive uh, for sensitive equipment or sensitive appliances. You know, in hospitals there are life support appliances that they they don't require light to even blink. If you are on inverter, most inverters change over times. When they are changing over, you will see a blink in the bulbs. Maybe when they take lights, inverter take over, the light will just blink. But the online UPS will not, you will not even see blink. So that is changeover time of approximately zero. So that is what separates inverter from UPS. Then let's look at the technical specification of inverter. An inverter will work normally if it receives an input voltage of 110, between the range of 110 volts to 205 volts. Between the input voltage between the range of 110 volts to 205 volts, inverter will work normally. But if the input voltage is less than 110, inverter may not work normally. Or if it is higher, much higher than 205, inverter may refuse to work formally. That's technical specification. Input. Then output of inverter is normally between 200 and 245. If it's getting above 245, that inverter is faulty. Or if you are getting output from inverter below 200, that inverter need to be well examined. It's faulty. That's technical specification that you need to know in solving problem on inverter. That is the technical specification that you need to know while solving problem on an inverter, so that when a client call you that my inverter is not charging, and you know how to use a multimeter, which we are going to teach you in the course of this program, you will check what is the input coming. If it is less than 110, you will know that it is the supply. If it is NEPA, then they should go and rectify the fault, or they should on generator. Immediately you are getting something above 110, that inverter will start charging. So if your client call you that inverter is burning or is getting hot excessively, if you check the output of that inverter, if it's more than 245, that inverter is faulty. So that is it. The system of an inverter system. So we are going to look at the schematic diagram of the operating system of an inverter. Inverter, a conventional inverter comprised of rectifier, which is the charging system, the oscillating circuit, which converts the DC from the battery to AC. Then the relay that switch between NEPA and backup UPS, and the power switch. That is just the main component of an inverter. So let's look at this, the schematic diagram. Let's assume this is the source. Our source means either NEPA. Our source is either NEPA or gen. When it comes here like this, it goes directly to the load. It goes directly to the load like this. This is our load. What are our loads? Fans, bulbs, and all the rest that we use in the house, TV. Now, it's also comes like this. It goes to the rectifier. This is the rectifier. The rectifier converts the AC from NEPA and gen to DC, which fed into the battery system like this. This is the battery, positive and negative of battery. And also this battery is also, the power from the battery is fed into oscillating circuit that convert DC to AC for our appliances like this load. The reason why I put this as dotted line is that it alternates between NEPA and backup power from the battery here. This is battery. If power from the battery NEPA is not available, this take over. If it is available, this go on standby. It go on standby. So, and there's a relay. There's a power relay here. There's a power relay here like this. There's a power relay here like this. This power relay is the relay that did the interswitching between NEPA and UPS. If NEPA goes, this relay will close, then the UPS will be supplying the load. If there is NEPA, this relay will open, then the NEPA will be supplying the load direct, then it will also be charging battery at standby. So this is the operating schematic diagram of operating system of a conventional inverter systems. Regular inverter only have this. Just tap from battery, then change it to load. Where other inverter like solar hybrids also have solar charger incorporated again from the solar array, then to battery, then with the help of inbuilt charger that work like this rectifier. So that is the schematic diagram of the operating system of an inverter systems. So questions and comments are welcome. Inverter load estimation. Inverter load estimation. As we are discussing earlier, after visiting our client premises and we discovered that they have 5 bulbs of 15 watt, we check 2 fans of 75 watts and 1 TV of 120 watts, then 1 fridge of 200 watts. Then we will now get to our table, then tabulate like this, put it as serial number, then load. What are the load that we have? What are the load that we have? We have bulb, we have fan, we have TV, we have fridge. Then the next thing is number. How many of them do we have? Bulb, we have 5. Fan, we have 2. TV, 1. Fridge, 1. Then what is the power rating or wattage of each? wattage of bulb 15, wattage of fan 75, wattage of TV 120, wattage of fridge 200. Now total wattage. Now we'll now calculate total wattage. Now 5 bulb that has 15 watt each, that is total wattage is 75 watt for bulb, 75 watt for bulb. Then fan 2 that has each is 75 watt, that's 150 watt for fans. Then TV 120, then fridge 200. Then we will not total this together. When we total this together now, 200 plus this, that is 320, 320 plus 150, 100 plus 320, that's 420, that is 470. Then plus 75. Take 30 from here, we have 545. Yes, 545 watts. That's total wattage. Now, inverter sizing. Now, our inverter sizing will now be 25% of 545, which is our total wattage. 25% of this. When we find 25% of this here now, 25% of 545. 25 times 545 equals this divided by 100. We get 136.25. So our inverter sizing will now be this now, which is 545 plus 136.25. When we add it together, we are going to get 681.25. So inverter that we are going to choose, the KVA or the VA rating of the inverter that we are going to choose must not be less than 682 approximately. So, and with the inverter that we have in town, we have 600 VA, we have 900 VA, some company has 850 VA. So we cannot choose this, but we can choose this, we can choose this. That is inverter load estimation. And this marked the end of the first lecture, which is Introduction to Solar and Inverter. Thank you for watching.